Thanks to some great Hello World examples out there on the World Wide Web, we got the Android tablet, the Nexus 7. It's an old one. I'll get into why or how I picked that particular tablet. There's some particularities about it. But we got that tablet, the Nexus 7, talking with our Arduino MEGA ADK board, which in turn talks to the Uno via I2C, as we've seen in previous episodes. In the last episode, we specifically got the Android talking to the Arduino MEGA using a Hello World example, which was awesome. It just proves that the hardware works and the very basic code does function. It's no small feat for me, so it's a great accomplishment. However, it really doesn't do much good for ROVer because the Hello World doesn't have anything specific to him. There's the app that I started to build 2 years ago. You probably saw that previous episode where you could tell he could get GPS coordinates through the GPS module already built into the tablet, and we even got accelerometer data, and there's a whole host of other things that we can get from an Android tablet, especially the newer ones if I choose to upgrade ROVer's tablet. But I mean, it's a great starting point, it's a great platform. So what we need to do now is get that custom Android application working with the Arduino MEGA ADK board. And what really got me hung up when I first kind of revived that custom app was Google's change of development platform. So going back 2 years ago, the development environment, their software was actually still in beta, and it's since gone full version. And that has consequently changed the way in which they like some things done. So they do provide some import and kind of migration tools. Unfortunately, I don't know if it's the way that I went about building the app or if a lot of other people kind of run into that same stumbling block, but the import did not work for me whatsoever. Basically, the app just crashed when I tried to run it or to debug it. So basically, I had to kind of piece it together, and of course, in the back of my mind, it's like, well, did I piece it together correctly? So as we tackle this next step of getting that custom app to work with the MEGA ADK board, that question kind of sits in the back of my mind. We've got the Hello World example working, we know the board works, we know the tablet works, now it's a matter of getting the custom app to work. So let's dive in. Let's begin by looking at the Arduino code. So we're looking at the ADK, the MEGA ADK board code. In this case, we're not even going to bother looking at the Uno code. The MEGA ADK and the Uno are still chatting with one another over the I2C protocol, but it doesn't matter for the purposes of our test right now, which is really to get the ADK board to speak with the Android tablet. So the same code that we used before, but I just wanted to hone in on what exactly is of interest for the purposes of our test now. And what I've done is kind of moved the key piece of code out of all the complex ifs, else, and all that stuff, just so we can basically make sure that the stuff's getting through without a lot of hassle. So the code's going to be included on ROVer's site as always. There's going to be a link on this episode's post to the previous episode where this code already is posted. But the particular part that we want to focus on is towards the bottom, and it's right here. So basically, we're sending two messages. We're sending message and message 2. And what you want to pay attention to are the commands. So we've got command text and then command speed. These are just things that I came up with. They'll probably change shortly, but for the purposes of working with what I already had coded, this will do. So basically, why we've got this. So when we send a message through over to the Android tablet, we want to indicate what kind of message. And there's two ways we can do that. Something we've kind of called command, and secondly, something we've called target. So by using those two kind of identifiers, we can leave ourselves a lot of flexibility for how we send stuff over to the Android tablet. You can imagine that there's all sorts of commands that we can come up with, and then target is kind of like a subset of that command. So if the Android tablet receives command A and then sub command B, what have you, you can do something different from command C and sub command F or whatever. So it just gives us a lot of flexibility. Who knows, how many commands we'll need and how many target types we'll need. So this just gives us a lot of room to move. So we've got two types of messages, one text, one speed. So this is going to be sent as numbers, and this is sent as text, of course. And how we interpret that over on the Android side of things matters. The third element in the array that we're sending here is the size. So basically, whenever we send something over to the Android tablet, we want to tell the tablet, the Android device, how much information to expect. So so over here we've got basically just a for loop that counts through the array size, and then it kind of specifies the value for the array size here. Actually, no, sorry, that's my goof. So array size is specified up top here somewhere. Array size 25. So here we're actually filling out the other value, the other elements of the array with the characters for hello. And hello is also defined up here. And basically it's the individual letters of hello world from Arduino. So that's what we're sending over as a text command. And then as a speed command, we're sending over speed wheel 1 and speed wheel 2 variables, which are here. So speed wheel 2 is this shorter number, speed wheel 1 is this longer number, and you might recall from the previous episode that in the loop on the Arduino, we are incrementing the speed wheel 1 variable by the number of loops that we're doing. And the reason for doing that is basically to tell us, to give us some sort of feedback that when we're looking at the Android tablet, that yes, the MEGA ADK board is still running through its loops and is continuously sending information over. So that's what this is about. And the reason for this stuff is basically to break down those characters, kind of similar to what we're doing here. So that's the ADK code. And like I said, it's included on ROVer's site. So let's take a look at the corresponding part of the Android tablet code. If you're not familiar with the Android programming stuff, which I'm not really either, there's a few key files. There's a whole bunch of files, to be honest, but there's a few key files that you spend a lot of your time in. And this is kind of probably the biggest one of them all. It's your main activity. So stuff that goes on within the Arduino, the Android application, they're referred to as activities. So your main activity is where typically the person starts when they're opening the application. So for the purposes of ROVer's application, the main activity is where I'm kind of dumping all the stuff for the time being, and then slowly but surely I'll move things out of the way. There are a few other activities that are already set up, such as what I've called face and what I've called the GPS tracker. And those are the activities that, if you may remember, you'll probably see it when we look back over at the Android tablet. But there's a kind of a cutesy minion type character that I came up with to give ROVer some personality. And then the GPS tracker, that's the face activity. And then the GPS tracker is basically an activity dedicated to collecting the GPS data and reporting it back. So otherwise, this main application actually has a whole bunch of stuff going on, but what's critical to us for the purposes of this test right now is how we're dealing with that stuff that the Arduino is sending to us. So in the Arduino, we saw that we're sending a text message, the command text, and we're sending a command speed message. So on the Android tablet, that's how, over here, that's how those messages are going to get received and interpreted. So, and you find that in the connected thread class, and specifically in the runnable section. So as soon as we run, we're going to send back a message from the Android tablet to the Arduino, so many A's, to acknowledge that we're communicating and to say hello back. So we're sending back a command text message, and we're sending back a command data message, but really, really simple, just a bunch of numbers, a static message. Again, just to prove that we're communicating back and forth. Where it gets interesting is in dealing with the buffer. So the buffer is kind of that parsing out that we saw on the Android side of on the Android side of things. Actually, in both cases, basically it allows us to send a lot more information than we would be able to otherwise by kind of piecing it out. So and that's what this input stream read buffer is all about. So basically, once we get into this run, we have a switch here that flips between two, for now, commands, the command text and the command speed. So the command text here is going to interpret, so here's a great example. We need to understand that it's text, not some other thing, so that we know how to handle it, right? So that's why we're defining what type of command we're dealing with when we're communicating back and forth. So when we receive a command text, we know it's text, and we deal with it as such. So we're going to use the text builder, the string builder, defined as text builder, and we're going to take each element of the buffer array and append it as a character. So that's what's kind of going on here. Next, if and when we receive a command for speed, we know it's going to be in this format. Right now we just got the two variables for speed 1 and speed 2. And again, we're going to basically reverse what we did on the Arduino side of things and back out and interpret those numbers and then again piece them together. Sort of just like we did with the append here, we're just piecing it back together. So that's how we're going to be able to see. Here, basically these are the run functions that post what we've got out to a particular variable that appears in the XML for the Android application. So in this case, we're posting it to a text view variable, and here we're posting it to a speed view variable. So that's basically the key part of this Android application code, and I can't possibly post the whole Android app, but I will share this main activity Java class or Java code on ROVer's site. And then if you have questions about the other stuff, just hit me up and I'll do my best. But as you know, I'm no pro. But yeah, so let's take the next step and post this stuff over to the Android device and post it over to the Arduino respectively. Wire them up through the USB cable. So in regards to the USB cable, basically there's a USB cable going from the tablet to the MEGA ADK board, and we do have a USB cable connected from the laptop to the MEGA ADK board, and that's really just supplying power for the time being until we connect the main battery over to the board. So yeah, so let's send it over and have a look. First, we'll take a look at the Arduino. Okay, so we're back over to the Arduino side of things, and we've got everything wired up. So I'm just going to, I just made sure that the tablet is actually turned on. So what we're going to do now is basically just trigger the serial monitor, and that'll force the app to rerun, as you've seen before. And what we should see, what we expect to see, is a message back from the Android device saying hello to the Arduino. So let's take a look. Serial monitor. I'm going to force a restart on the Arduino. There we go. I got the request up on the Android device. I'm going to choose the ROVer application as we saw before. It's coming up, and there we go. We've got our Hello World from Android on the Arduino serial monitor. And we got that static wheel position. So great. So we've proven that the Android device is sending messages to the Arduino, and now we just need to demonstrate the reverse, that the Arduino is sending messages to the Android device. So let's take a look at that next. Alright, now we're looking at the Android tablet, and what I'm going to do is I'm going to reinitiate the script on the Arduino MEGA. It'll ask us to launch the ROVer application. So here we go. ROVer. And just once for now. And ROVer's coming up. So there's the minion I told you about, just a cute little thing. So it's deactivated by a touch, and awesome. So up here we see Hello World from Arduino. So it's basic, and you see it's flickering, so it's going through the loop, and that's why it's flickering. You'll see that the accelerometers are working as I tilt the Android device here. Those values on the X, Y, and Z are flickering. And finally, our speed values. So this was key for our kind of proof of concept here, that we are getting our custom values out from the Arduino onto the Android tablet. We have a static value, and we have an incrementing speed 1 value. And the only reason it doesn't go any further after that is because I probably forgot to mention it, but there's a reset in the code on the Arduino. But awesome, there we have it. Don't you love it when things work out? So yeah, that's pretty awesome. So we've got ROVer's brain functioning, and the Android tablet is successfully talking with the Arduino MEGA, which is in turn successfully talking to the Uno, as we know from before. So we didn't look at that, but anyway, trust me, it works. Yeah, so the next step on the brain surgery front will be to get the actual motor values out to the Android tablet. We already know that we can send numbers successfully, and we already know that the Android device can successfully request information from the Arduino. So it's really now just a matter of connecting the dots, basically connecting the values that we've already seen the Arduino is able to get from the motor controllers, from the roboclaws. So we now just have to basically just add the extra code to take those values and send them over to the Android tablet. And not quite sure how I want to go about that yet, but that's going to be the next thing on the brain front. I don't think that's going to be the next episode, because I think there's plenty of other stuff that I've been procrastinating on, namely soldering. But I tackled this in order to address the soldering. So now I kind of have a good sense of where things need to be within the board, how long wires need to be, more or less, that sort of stuff. So I feel a little bit more confident in tackling that stuff and making things more permanent. So yeah, so that'll be the next thing. A little bit more boring, maybe, but I don't know. It's fun too, because it's kind of part of the design and the architecture, and you get to work with your hands. Less keyboard, more tinkering. So until next time, and any questions, suggestions, criticisms, please message me. Cheers.